Ready? Okay, so I guess we'll go ahead and get started. Okay, so my name is James Whitaker. I'm a test lead. I own AppCompat in the WinSE group. And today I'm going to talk about the bug flow process. So if you have any questions as I'm going, if I'm kind of skipping over something or I missed something that you'd like to me to go into a little bit deeper, feel free to ask questions during the presentation, and we'll stop and just take questions along the way. Okay, so basically in WinSE we deal with three types of bugs. Of those three types of bugs, there's different subsets, but there's three major categories, and I'll go through each one of those major categories. The first one is SP only or service pack only bugs. Service pack only bugs are bugs that are shipped in a service pack. So these are, if they are security bugs, then they're not publicly known. They're a security exploit that we found internally that we don't feel is going to go public, so we'll put it in the service pack. Or they're non-security bugs, something that hasn't been reported by a customer, or if it is a customer issue, it's limited to a very small subset of customers and they've got an acceptable workaround, so they don't need it right away. They're fine with it waiting. Or it's a DCR or a backport from one of the newer operating systems or something like that, but it's a bug that isn't really time critical. It's something that can wait for a few months until our normal service pack ship schedule. These bugs, so in a few minutes I'll flip back to Product Studio. I'll show you the way that we mark some of the bugs, but the way that you can tell these bugs, there's one field titled dist method that'll be set to SP. That denotes that it's a service pack only bug, so the only way that it'll get out of Microsoft is in a service pack. Oops. The second type of bug is a GDR, or a general distribution release. So these are bugs that go up on, or fixes that go up on Windows Update. They get downloaded, and they're broken down into categories. There's security bugs or MSRC bugs, there's critical bugs, non-critical bugs, driver updates, all of those type of bugs on Windows Update. So these are bugs that if they are security, they were either reported to us externally, there's a known exploit that's out somewhere, somebody who reported the exploit to us is threatening to go public with it, or customers being impacted by, on a large scale and they really need to get a fix out, or somebody reports that it affects their company or their individual computer, but we feel that it's such a widespread problem that we want to get a fix put out to everybody faster than we could as a service pack. So we'll send it out as a GDR. So I should say service pack bugs. A service pack generally has a life cycle of somewhere between 9 months and a year and a half, somewhere in that neighborhood. It takes us to put out a service pack. GDRs have a turnaround time of anywhere from 30 days to a month or two, somewhere in that neighborhood. So they're a lot quicker to put out, and a lot of that cycle depends on how critical they are. If they're a security release, is there an exploit known, that kind of thing. So I said here that they're released on a 5-week schedule. The 5-week schedule really starts from the point where we have a fix and the fix has been tested in-house, and I'll go through that process a little bit, and we've got a really solid package put together that we're ready to release. Then we go through this 5-week release process where we do a broad test pass and a few things that I'll talk about here in a minute. And they're denoted by the same Product Studio field dist method. It'll say GDR. The third major type of bug is a QFE. A QFE bug is a bug that we'll send out to a major customer or a major group of customers as they request it. So these are bugs that won't go up on a Windows Update. We'll hold them, we'll develop the fix and put it out on a server where PSS, or our product support team, can pick it up, and then the company who originally reported it to us, we'll give it to them, and then if another company or another individual hits the same problem, then PSS can give it out on a case-by-case basis. So these are generally not, they're not security bugs. A security bug we don't, or a security fix we won't release as a GDR. But they're generally bugs with really limited customer impact. Good example of that would be one we did a few years ago for the Canadian government, where they hit a hard limit of connecting printers to a print server. I can't remember what the number was, but it was like 8,000 printers or something like that they connected to one print server. It's not something that the general customer does. They were the only person that ever complained about it, or the only company that ever complained about it. So we did a QFE, sent it out to them, but we didn't send it to anybody else. Nobody else requested it. They may be redistributable, though. So occasionally we'll get an issue where, say, Sony will report an issue to us on one particular line of computers. So say there's Sony Vaio, one particular model has an issue with Windows XP, and it's holding up their release of that particular model. So they'll report the issue to us, we'll fix it, and we'll give them what's called redist rights or redistribution rights, so they can pre-install that hotfix on the machine before they send it out. So that's kind of a subset of a QFE. And again, the Product Studio field dist method will be set to QFE or QFE wait. So the question was, does QFE make it into a service pack? And yes, it does. I should have mentioned that the service pack is kind of the catch-all of all bugs. So every single bug we release, if it's in any of these categories, will get into the service pack. So we try very hard, because everything comes out of one code base essentially. We don't release anything that's not going to be in the service pack, ultimately. Yes, sorry. Okay, so the question was, if a QFE, if a customer reported that they wanted a change that wasn't necessarily a bug, but they needed a DCR or a design change to Windows to suit their needs, would we take it, or would we give them a QFE for it? And then would it ultimately get into the service pack? So the answer is, if we did take it, yes, it would ultimately get into the service pack. So no, generally we turn those down. We won't do a feature change to the product just for one customer that isn't a bug. Occasionally those will get escalated if it's a huge blocker. They'll be reviewed at a high level, and if it's felt that the design change would benefit enough customers in some very limited times, we'll take those. But as a rule, no, we don't take any new features in service packs or QFEs. Okay. So the question is, for a redist, do we do more testing than a hotfix or a QFE? And yes, we do. So the level of testing I'll get into in a little bit. The service pack is by far the best, most tested fix that we send out. So anything in a service pack, it goes through, like I said, about 9 months to a year or so of testing. It gets tested by every component owner, and it goes through a lot of testing. A QFE really only gets a small amount of testing on it. For those, mainly we rely on the company that we're going to release it to do some testing, tell us that it's good, and then we'll run it through a small set of automation in-house and a limited amount of testing by that one particular component owner. A GDR actually goes through a broad test pass, and that's part of the 5-week cycle. So a GDR will get tested by the entire WinSE team, all component owners. A redist, even though it's a QFE, it'll also go through that GDR 5-week test cycle. So yes, a redist will get tested to the same level as a GDR. And part of the reason on that, once we give redist rights out, then we don't have as much control over the distribution, so there's a bigger chance for it to get out to a wider distribution of customers, so we want to put it through some more testing. Yeah. Do all QFEs, okay, so the question was, do all QFEs qualify for GDR? No. No.
Then how do you decide which one to go for GDR?
Okay, so the question was, how do we decide which QFEs we decide to take as a GDR? So there's a triage process, and there's what's called a war meeting that happens every day or a couple times a day where we discuss these. But And there's varying bars depending on the different types of bugs, but generally the rule of thumb is if one customer reports it, and they're the only customer that's reported it, and we really feel that it's not going to impact any other customers, then we'll leave it as a QFE and not send it as a GDR. One of the main reasons for that is the risk of regression. We do, compared to the entire world and the entire install base of Windows, we do a fairly small set of testing. So we try to be really careful about the bugs that we send out, because when we do send out a GDR fix and install it on millions of computers, there's a chance that it's going to break something else, that there'll be a regression in that fix. So we try to hold a really high quality or a really high bar on the GDRs that we send out. So if the customer will accept a QFE and it's just going to affect their company and we don't feel it'll be a really widespread problem, then we'll just send a QFE. If a customer does report it and we find that it's a security issue, then generally those will get escalated to be a GDR. We don't ever send out a security fix out to just one customer or a small set of customers. And the reason for that is there's a high chance that once we put out a fix to a small amount of people, that a hacker will take that fix, do some reverse engineering on it, and use it as a roadmap to create a virus. So anything that's security related or we think is exploitable, we try to roll out as a GDR so it goes out to a wider install base. Does that answer your question? Yeah. Okay. Great. Okay, so let me go through the GDR bugs first, and I'll kind of walk you through the process, and then we'll go through the other two types of bugs. So, did I miss one? Sorry. There we go. That makes more sense. Okay, so GDR bugs. Okay, so initially a bug's open. Generally they're opened by the CPR team or the critical problem resolution team. That's a team of engineers that deal with customers. So customer will call, they'll report a problem that they're having in their environment. The CPR engineers will work with them to triage that problem, see if it's a known issue, if there's already a QFE that we could provide to them that would fix their problem, or if there's a workaround, if it's something that they're doing wrong that's causing the problem. Once they determine that it actually is a bug in Windows, it's not a known issue, we don't already have a fix for it, then they'll file a bug in our database. Once they file a bug in our database, they'll assign those to ACT test. So there's in the Product Studio database, there's an assign to field, and in the assign to field, they'll assign it to ACT dev, which is an alias that'll send out a mail to a whole group of developers. The dev leads have a meeting once a day where they review all of the bugs that are assigned to ACT dev, and they'll assign them out to four or five, I think it's four, dev leads to triage in their own meetings. They'll triage those, and then they'll assign them out to individual developers. So at this point, a date field called triage accept is set. So that's the date. And there's a lot of date fields in Product Studio that we use to measure the time that it takes from when a customer reported an issue to when we actually get them a fix. It's called the end-to-end time. So the triage accept field is one of those fields that we mark as this is the day that a developer picked it up and said, okay, I'm going to start working on it. Then it goes into a dev triage state. So the dev team, once it's assigned to an individual developer, it'll kind of work its way through that person's queue. As soon as they start working on it, they'll generally do one of three things. They'll resolve it as by design, won't fix, or duplicate. These are basically bugs that they're not going to fix. Or they will assign the bug back to a tester, which for a GDR bug will be the first time you see it. So if they get a bug and either they can't get a repro on it, the CPR engineer doesn't have enough information for them, or they need some follow-up test information, they'll assign it to a tester, ask you to set up a repro, and get them some more information so that they can work on it a little bit faster. Or they'll create a private. If the CPR engineer gives them enough information, or they're able to find the problem relatively quickly, then they'll go ahead and create a private. As soon as they create a private, they'll send the private out to the customer who reported the issue. They'll run it through a BVT, which is a build verification test, and there's a whole team and the test org that does that. That's basically a set of automated tests that they run against it to find really common problems. And they send it up to their dev lead for a code review. So at that point, a date field in Product Studio named private gets set. And that's the date, that they release the private. So, go ahead. So, won't fix. So, okay. So by design means that that even though they hit a bug, Windows actually was doing what it was supposed to do. And a good example of that is an application will break for some reason. Well, we had an example of that not too long ago where a third-party application was using a public API and they were overloading it using an attribute that they shouldn't have used, right? Which didn't actually do anything in RTM. But then we fixed that, so we started actually interpreting that attribute. As soon as we did that, then it caused this application to break, but it was still by design, so we didn't fix it. We said it's already working, so the customer needs to go fix it. So that's by design. Won't fix means that there is a bug, or there's most likely a bug in Windows, but to fix it, it'd be such a big change, and the risk of regression would be such a big change, and maybe there's a workaround available. So we say, even though it's a bug, we're not going to fix it. The risk is just too great. Okay, and a duplicate's, obviously there's already a bug filed, and that's just a duplicate of an existing bug. Okay, so once they've done one of those three things, then essentially from our side, the next thing we'll see is the private testing. So we'll get an email from the developer, who you've probably already worked with on this bug at this point. They'll send you an email with a link or a pointer to the private that's gone through BVT testing, and they think it's fairly solid. And they'll want you to do some testing on the private. So it's very important at this point. Some of the bugs that we get in from CPR or from other teams, maybe the repro steps look really clear, but when you run through the repro steps, even on the broken build, maybe you won't get a repro. So it's very important to get a repro first without the private, actually see it fail, then install the private, and then see that it's actually fixed. To make sure that you're actually hitting the repro in the first place and see that it actually fixes the problem. And then at that point, you should do some amount of functionality testing on it. So you make sure that the private actually fixes the bug, then do some testing around that area to make sure they didn't regress anything else. That's a fairly easy catch. So if you find an issue in the private, at that point, you just assign it back to the developer, make a note in the bug, and send them an email. Say, hey, I found a problem with your private. You need to work on it a little bit more. Otherwise, the bug will wait for the customer to approve the private. So both of those things need to happen. The tester on our side, one of you guys who's working on the bug, needs to say that the private's good, and the customer who actually got the private to test it in their environment, they need to come back and say it's good. So as soon as both of those things happen, as soon as the customer comes back and says that it's good, then the private approved field gets set, and the bug's assigned back to dev. As soon as the developer gets both of those pieces of information that both the teams have signed off on it, then they'll file a build request, so they'll check it back into the source depot, so now it's in the depot and ready to be built, and then they'll fill out a web form that tells the build team to build that set of binaries, package them up. Okay, so once that's done, it's gone through all the testing, and before it actually gets built, the bug gets sent to WAR. So WAR I talked about a little bit. That's that meeting that we have once or twice a day where all of the active bugs that have been set to request approval get triaged. All the leads will go through them. In that meeting, the dev leads are there and all the test leads are there, some of the program managers. And they'll kind of go through the impact of the bug, the impact of fixing the bug, the customer impact of the bug, and decide if it's something we should fix or not. So as soon as they approve it, then it gets for a GDR, it gets checked into at least 2 branches, and I know that'll get covered later on in the week in more detail, but at a minimum there's going to be 2 branches, and that's important for testing. It'll get checked into the QFE branch where all the GDRs are built from, and also to the SP branch where the service pack is built from. So you'll need to test on both of those, and I'll cover that more in a minute. The bug gets resolved as fixed, and it gets assigned back to test, and the final GDR is built and run through BBT. So again, as soon as the official build comes out, the official package, it gets signed, it gets all that good stuff, and then it runs through the BBT process again, verify that the final build package is good and that it doesn't have any basic errors in it, and then it'll get assigned back to test, so you'll get that build again. Should look just like the private, except now it's the final package that the customer is going to see. It's been signed, and it should be the last package that goes out the door. So as soon as you get that package, you go through the testing again, make sure that the package, again, test without the private, or test without the package, make sure that the error repros, install the package, make sure that the error goes away, do some functionality testing, make sure that the package didn't break anything else. You verify a few other things that are covered in the GDR checklist, which again will be covered later on this week, but basically that's a checklist with 20 to 30 items in there to check. You check everything from like that the binaries actually landed, make sure that there were no errors in the infs and that kind of thing, that the right versions of the binaries came down, that all of the dependent binaries got laid down, all that kind of thing. So then you'll go through as the component owner. So let's say that your component's shell, and this bug is in shell. Now you'll go through your shell tests, where you go through, depending on how much time you have, a few days and how automated your tests are, that kind of thing, a few days to a week or so of testing to where you feel really comfortable that the fix isn't going to break shell, and that the fix is good. Once that's done, then it goes into this 5-week release process, where once we get to the end of that 5-week release process, in the final 2 weeks is what's called the broad test pass. Broad test pass is where all the other component owners get all of these fixes that have kind of built up in the queue. Typically it's like 5 to 10, somewhere in that neighborhood, of GDRs that are ready to be released. They've gone through this checklist, they've gone through the component testing, and they're all ready. And they might be in different components. There might be some in directory services, some in shell, some in GDI, and all of the component owners will test it. So at that point, I own AppCompat. I'll get all of the bugs and I'll run them through 2 weeks of an AppCompat test pass to make sure that none of the fixes broke anything in AppCompat. As soon as that broad test pass is done, the whole 5-week test pass is done, everybody's signed off on it, all the testing's complete, then they'll go through a final release process where the release PMs do some other things to it. They verify that all the file versions are right and that kind of thing. And then they'll publish them up to Windows Update and a few other internal sites, verify a lot of other things on it, and then they'll get released to Windows Update. Once that happens, the final fix posted date in Product Studio gets set, and we're essentially done with the GDR piece of it. Make sense? Okay, so at that point the bug will get resolved, and it'll get resolved back to the person who opened it, unless it's a CPR engineer, in which case, well, it should still go back to the CPR engineer, but in certain cases you have to help them out. But once the bug gets resolved, the GDR goes out, then you also need to go back to the service pack, and this might take a few weeks depending on where we're at. Like XP, right now, if you did an XP GDR, the service pack build would probably come out before you completed this 5-week test pass, because we're building XP SP2 service packs every day currently. But Windows 2000 SP5, we're only building those service pack builds, more on like a weekly basis. So it might take a week or two for that build to come out that also has that GDR checked into it. As soon as that happens, you need to do the same thing. Install. So, for instance, if you're doing a Windows 2000 and the next service pack that's going to come out is SP5, you'll install SP4, verify that you hit the bug, then install that build of SP5 that contains the GDR, verify that that fixed it. Once you do that and you do some minimal amount of testing, then you can close out the bug. But it's important not to close it until you verify that it's in the service pack. That happens occasionally where a GDR will get fixed, but it doesn't get checked into both trees or branches. It just gets checked into the QFE branch and not the service pack branch. So just make sure you watch both of those. All right. Oh, I also should say, if at that point, if you find a bug, like so let's say that you find that it's not fixed in the service pack, the bug's already resolved. You don't reactivate the bug, you file a new bug, because the GDR is already out, and that's assumed to be good because it went through all the testing. You'd verify that, of course. But if the GDR is good and the service pack's, that particular bug in the service pack's broken, you file a new bug marked as a regression to fix that. All right. Any questions about GDR bugs? Okay. So QFE bugs, essentially they're the same as a GDR bug with the following slight differences. So, let's see. Okay, so QFEs won't be included in the broad test pass, like I was saying, unless they're redist, of course, but they won't go through that 5 weeks of testing. So they get released basically as soon as the component tester says that they're good and the company that reported the issue says they're good. They're ready to go. And they won't get released on Windows Update, but again, like I said, they are available for PSS to hand them out to companies as needed. Questions about QFEs? Sure. Yes. Yeah, that's okay. So the question was, tell me if I got it right. So let's say you've got binary a.dll that's got a problem in it, and we've either put out a fix or say we haven't put out a fix for it yet, and then you've got another bug that another customer reports that also is in a.dll that they need a fix for. Bug 2 will also contain the fix for bug 1. That's called an encompassed bug. Because all the fixes are cumulative and we've just got one branch for all the QFEs, all of the previous bugs will go out. And that's actually one of the bigger problems that we have right now that we're dealing with, is when you release a GDR, that GDR will also contain all the QFEs that went out beforehand in those same set of binaries. But they weren't tested to the same level. So those do get sent out. Is that kind of what you were asking, or? Okay, so the question was if fix 1 is a problem for customer 1, but not for customer 2, and then customer 2 asks for a fix, asks for bug 2 on that same DLL, they're going to get that first fix no matter what if they put their request in second. We never go back in time and take certain fixes out. They have to take all the current fixes that went out as a GDR, which absolutely does have the potential to cause a problem later on. So say we did a QFE in that first binary, we sent it out to the customer 1 and they were all happy with it, didn't have any problem. Customer 2 gets it, that new fix or that new QFE that we put out, and it contains the fix for bug 1 that causes a problem in their environment. That does happen occasionally with QFEs, and essentially when that happens, then we just have to file it as a regression and fix that problem. But we don't ever try to pull out, this fix and stick in a couple of fixes, but not this one and maybe that one. We don't mix and match that way. It's kind of an all or nothing for that binary kind of thing. So the question was about file dependencies. So we try really hard not to make new binaries, new binary dependencies, but there are hard-coded old dependencies. So if fix 1 has 2 binaries in it, and they both get shipped out and they're dependent, if fix 2 that comes in only needs the first binary, but it's dependent on the second one, they have to take both of them. They have to take the dependencies. And we actually have a tool that does some dependency checking in a database that lists all the known dependencies, so that during the build process, if if a developer only requests one binary to be built, it'll go through this check in the database and see all the files all the binaries that are dependent on that binary they requested, and automatically include those in the package. Does that answer your question? Okay. So the question was, do we maintain any separate branches for major customers? And no, we just have one branch for QFEs. The QFE branch will actually get separated from the service pack branch at some point, and that's really to maintain more stability in the service pack branch, so that we can really lock down the amount of check-ins that go into a service pack branch right before beta, or right before we release the service pack. And as soon as we release that, then all of the fixes in the QFE branch get integrated back in, and then we go to the one branch. But no, it's one branch for everybody. And that goes to file versioning, so that we don't have a lot of different file versions out. We just have, a customer can always pick up the latest file version. Yeah.
Microsoft delivered the fixes on SP1. Now, Microsoft decided that this fix will not be included in SP2.
Mm-hmm.
Now, when the SP2 is released, and if the customer install this SP2, do we need to reinstall the fix again? Or how we...
Right. All right. So the question was, if a customer requests and we send out a fix, say it's built on the SP4 sources, and it goes out and it's meant to install on SP4, but we don't include it in SP5, then when we release SP5, will that overwrite those fixes? The answer is yes, it would overwrite those on the customer system, and that's why all QFEs have to go in the service pack branch. So when you install SP5, that fix will already be in SP5. We don't, and that's one of the reasons that when we evaluate the QFEs, we don't just build a QFE and not include it in the service pack. Right? We include every QFE gets put into the service pack. And that's why. So when you install SP5, it will overwrite all of those fixes, all those QFEs that you already had on your system, but the actual fix will be included in SP5, so you don't lose the functionality.
What we heard that in war room it is decided which QFE should be included, which should not be. Suppose this is not included, then what will be the problem?
So if that'd be a breakdown in the process. But if that did happen, then yeah, the fix would get overwritten and the customer would lose the fix. And that situation would be is if we put out a QFE that installed on SP4, but we didn't put that fix into the SP5 branch. So that, by design, that should never happen. That has the possibility of happening accidentally, which is why it's so important to also verify that the fix got into the service pack as well as in the QFE before you close the bug. Yeah.
What is the more substance to not be reproduced in the step? The example is to give for Canadian consumers.
So the question was, what do we do about bugs that we can't reproduce in-house, going back to the example that I gave with the Canadian government with 8,000 printers. So for that particular scenario, we actually did reproduce that in-house by installing null printers. We just wrote a program that installed 9,000 null printers. So we'll try really hard to reproduce everything in-house. If we can't because of a hardware limitation, that does happen occasionally. Usually that happens with bigger customers, and usually they'll give us enough information back, enough debugging information that we can produce a private, and then we rely on them a lot to tell us that the private's good, and then we do our regression testing in-house to make sure that that fix didn't actually break anything. The example of that kind of fix would be maybe we do a fix for like Boeing or for GM that it's in their manufacturing plant, maybe that runs a robot or something that we don't have. Right. So that does happen. We do get bugs from time to time that we can't reproduce, and mainly we rely on the customer to say that the fix is good. And then we just test around it. Okay. All right. MSRC GDRs, and there are differences from GDRs. So a subset of the GDRs, which are all the Windows Update fixes, are MSRC bugs. These are Microsoft Security Response Center bugs, and these are a special class of bugs because they're security related. And these bugs come from a few different areas. Occasionally a bug will get found in-house and get escalated through MSRC, but in general the MSRC bugs are security bugs that are reported by an outside customer or an outside user who finds a security hole. And generally they'll report them in one of two ways. There are consulting firms that will report the bug to us and say, hey, we were doing some testing for a client, we found this that looks like a security hole. You know, we just wanted to tell you so you could fix it. Let us know if you fix it, right? And generally they want credit when they fix it. So those are a non-publicly known security exploit that comes in through MSRC. And a lot of times when they report those, they'll give a time limit. They'll say, okay, I'm not going to go public with it for 60 days or 30 days or whatever, and we'll try to work with them and try and get a fix out before that happens. The second type of MSRC issue is one that is publicly known. So say somebody writes a virus for an exploit that we don't know about, or MSRC has somebody who's looking on the internet and finds somebody talking about an exploit that's not publicly known or that we don't know about. Or a consulting firm reports it and says, I'm going live in 2 days with it. You've got 2 days to fix it or something like that. So that'll be a bug. That'll obviously be a higher priority bug. All of the MSRC bugs are the highest priority issues because we want to get a fix out with enough lead time for customers to install the fixes before somebody has time to exploit the security hole and write a virus for it. So generally the MSRC GDRs follow the exact same process, except that they're watched a little closer on time. MSRC watches the bugs, and if they're going through the process and the security exploit becomes public, then obviously it gets sped up and we try to push out a fix quicker. But some of the differences, they get assigned to test first. So generally these are bugs that come in through MSRC as opposed to CPR. So MSRC doesn't necessarily have a team of engineers that are out there reproducing the issues. They'll just file the issue, make sure that it looks legitimate, and then they'll assign it to one of our testers to reproduce it in-house up front. So we kind of are doing the work of the CPR team. And obviously the privates don't get released to the customer until we're ready to release the full GDR. So we hold really firm to the rule of never releasing any security fix to any one person until it's ready to go on Windows Update, so we can give it out to everybody at the same time. Obviously the reason for that is if you give it out to one person, then it gets leaked around a little bit on the internet. Somebody has time to write an exploit for it and write a virus or something. Generally they're open through Ralph Hood. You'll see his name quite a bit. He's the PM that tracks all of the MSRC issues. So those are the major differences between those and the GDR.
Are the MSRC GDRs different cycles than normal GDRs?
So the question was, do these MSRC issues go on a different cycle than normal GDRs? And the answer is no. They pretty much go through the same cycle as a GDR. They go through that same 5-week broad test pass. We try to get them into the pass and have everybody test them in the same week and all that kind of thing. The only difference is a GDR might take longer to get into that 5-week cycle, whereas an MSRC issue is generally expedited, so it gets pushed to the front of that developer queue. So if a developer's got like 10 issues that they're working on, he'll push the MSRC issues up to the top and maybe get those out first. And then the only The only thing to differ for that is if a GDR was publicly known, or sorry, if an MSRC issue was publicly known, then it might go out sooner than the 5-week test pass. If there was a case where there was like a virus that was already out, then we'd push a fix out in a few days as opposed to a month. Okay, so those are all the hot fix type bugs that we deal with. So back to the service pack bugs. So in here I'm just going to cover the bugs that are service pack only. So like I said before, all of the previous types of bugs that we talked about will go into the service pack as well, but these are just the bugs that are only going to go into the service pack. So again, these are the lower priority bugs. These are the bugs that are found internally by testing. Maybe they're blocking a test from running. Maybe we just found them through some ad hoc testing, or somebody internally reported them, or a company reported the bug, but it's kind of more of an annoyance to them, and there's a workaround that they're happy with, and they're not really pushing for a QFE, so they're not really time bound, so they have a little more time. And if possible, we like to run everything through this cycle only. It gives us a lot more time to test it, and generally the quality bar is a little higher on them. All right, so like all bugs, they get opened in the Windows SE database, and I guess let me just flip over real quick and show you what that database looks like. So, have you guys all seen Product Studio yet, or? Okay. I won't go through a whole demo on that, but when you open up Product Studio, if you do register products, you can go through this list of thousands and thousands of databases until you find the Windows space SE database. That's the database that all of our bugs are tracked in for service packs. There's also a core database that all of the bugs for future products go through that you may use from time to time, but essentially for all of the bugs we're going to talk about, they all go through here. So some of the key fields, the title, the path. This shows the component that it's in and the component breakdown. So you can see this is a Windows 2000 bug. It's in administrative tools. This is assigned to closed, and the status is closed. So this bug is done. We should never have to do anything else with this bug. But they do all stay in the database. We never flush any out, so we can always go back and see if it's a known issue or some more information on it. Description. That's just kind of the running description of the bug. Sometimes you'll paste emails in there, any kind of notes about private testing, anything that you want in the record for everybody else to look at if they're going to work on the bug. Repro steps, that's just a separate field just for how to reproduce the bug. And then these 4 fields down here that I was talking about, triage accept, private approved, and final fix posted. Those are the 4 date fields that I was talking about for the GDRs. And those are how we, determine if we're getting all the fixes out in goal, that kind of thing. Okay, so and the dist. The dist method was the other one that I was talking about. So this is SP. So this is a service pack only bug. It'll only get released through a service pack. Okay, so service pack only bugs, they can get opened by a variety of people: CPR, internal test team, partner test teams, SQL, Exchange. All those people can open up bugs. Anybody else can open up a bug in our database. The bug gets assigned to ACT test, which is just like ACT dev, except ACT test gets triaged by all of the test leads. So every day, all of the individual test leads will run a query, look at all the bugs that are assigned to ACT test. Anything that's in their component, they'll pull out and assign to one of their testers. Occasionally, if somebody who's really familiar with our process, they'll file a bug in the right component, but generally it gets just filed under like Windows 2000 all, and then somebody has to, and gets assigned to ACT test, and somebody has to go in and put it in the right spot. Okay, so the test leads will look at it, or the component owners, the individual testers. If you own, like, say you own desktop apps inside of the app compat, you'll kind of look through this database every day, and if you see a bug that really looks like a desktop app compat bug that's just assigned to ACT test, go ahead and assign it to yourself and start working on it. Otherwise, the test lead or one of the other test leads will assign them out. So the first thing you want to do when you get it, read through the repro steps, set up a duplicate environment, trying to repro the bug and get it to break on your machine the way that the customer got it to break, or whoever reported it, the person who opened the bug. Once you set that up, you want to reproduce the issue. You should already have a kernel mode debugger set up on your machine at that point. So hopefully if it's a blue screen or an AV access violation, it'll break into the debugger and you can check your symbols, make sure your symbols are right, and then start debugging it a little bit. At the very minimum, you want to know the build number that broke. If it's a service pack, and you should do that on all the bugs, but if it's a service pack only bug and you've got a little more time, and time is kind of determined by where you're at in the ship cycle. If we're like 3 days away from shipping beta, then you probably want to just escalate this right away. Just give it to a developer and have them start working on it. If we've just shipped beta and we've got a lot of time, then you want to dig into it a little deeper so you can give the developer more information when you do the handoff. So you want to find the build that it broke in, the binary in that build that actually broke, and then the function or the check-in that introduced the regression. All right. And then, if you need to, you can update the repro steps in the bug. All right. So if the bug doesn't repro, which happens quite a bit, and you get a bug assigned to you, it's kind of a sporadic thing or whatever. You want to talk to the person who opened the bug and try and get more information from them. Maybe they've got a different hardware configuration, they've got different applications running on their machine, or their environment set up a little bit different. You want to kind of work with them and get as much information out of them as you can so you can set up a repro as close to what they're doing as possible. If you still can't get a repro, done everything, and generally before you resolve it out as no repro, you want to get the person who opened the bug to agree to that. Maybe they say, oh yeah, I played around with it a little bit, I had a dirty environment, I had an old build of the service pack on my machine, and once I uninstalled that, I can't get it to repro anymore. It looks like it's really not a regression. Then you resolve it out as no repro and assign it back to the person who opened it. Once you do that, then they can escalate from that point. If they feel like it is a bug and you resolved it as no repro, then it'll go back and forth a little bit. But generally you can work it out with them and figure out what they were doing to get it to repro or what the problem was with their system. If it's an internal tester that gets a repro on it, then that's good, because then you can just go over and use their debugger and work on their machine and see what actually broke. If it's an external customer, then it's a little bit harder, somebody in a different group. Okay, so assuming you do get a repro on it, got it broken into the debugger, got your symbols checked, everything looks good on the bug, and you're ready to send it to a developer. So you'll assign it to one of the 4 dev queues, and hopefully by the end of this week or the end of next week, you'll know which dev queue you should assign it to. But they're broken down by the test leads. So the first one, ActDev AG, that's Andrew Gross. He's the dev lead. He owns a certain set of components, so you'd assign it to him if it's in one of those components. So, for instance, in my area, AppCompat, if I found an AppCompat bug and I was ready to assign it to a developer, I'd assign it to that first one, ActDev AG, Andrew Gross. He's the developer that owns AppCompat. And then it'll go through their same triage process, just like the QFE bugs, except generally these aren't as high a priority, so they might take longer to get out. So a GDR bug, once it's assigned to a developer, you might get a response back in a couple of days. A service pack bug might take a couple of weeks. But you should every so often just ping the developer, send them a mail and say, hey, what's the status on this? Can I get you anything else on it? You need any more information, that kind of thing, just to make sure that it hasn't fallen off their plate and that they're still working on it. If it goes too long, then generally they'll assign it out to another dev to work on it, or somebody on the core team to get some help. So the developer will work on it as soon as they figure out what the issue is and decide that it is actually an issue and that it's something that they think they're going to fix. Then they'll create a private, or they'll resolve the bug out as won't fix or duplicate or that kind of thing. Just like the GDR. Once they create a private, then it gets assigned back to the tester. You'll take it from that point. You'll install the private, just like the GDR. Work through that whole process again. So, like I said, the developer might resolve it as won't fix or by design, just like the GDR. If they do that, then it gets sent back to the person who opened the bug, and same thing, they have the opportunity to escalate it if they don't think that was the right decision. Private testing, just like the GDR, verify the private again. It's critical that you actually get the bug to repro on the system, then install the private, make sure it's still repros. Again, do a certain amount of functionality testing, make sure that not only did it fix it, but it didn't break anything else that's really obvious. If you find an issue with it, just assign it back to the developer. You don't need to open another bug. Just assign it back to the dev. Otherwise, you send it to WAR for review. They go through the WAR meeting, assuming they're approved. Then the approval status field in Product Studio gets set to approved. It gets checked into the source depot by the developer, and they do a build request, just like the GDR. If it gets rejected, the approval status gets set to reject, and the bug gets assigned back to the person who opened it to, again, go through that escalation process. Yeah. Who sends it to WAR? Yeah, so generally you'll work with your lead on it. You don't generally, well, shouldn't say generally, always. You want to, I'm sorry, I didn't repeat the question. The question was, who sends it up to WAR? Does the component owner send it up, or the tester, or the dev, or who sends it to WAR? So generally it's the test team. If you're testing it and you feel the private's good and you're ready to go to WAR, you'll want to send a mail to the developer who worked on it, your test lead, let them know that you're going to approve it, and then give them a little bit of time to come back and say, oh, wait, we got something else or whatever, because they're the ones that'll have to talk about it in WAR, so you want to make sure they're prepared, right? And then you just can set, actually, sorry, they just changed that process, so yeah, it is the test lead that'll need to recommend it to WAR. So yeah, tell your manager or your test lead, they'll recommend it to WAR. In some cases, they'll want you to go to WAR with them to represent the bug and talk about it if anybody has technical questions about it. The developer will talk about it, and then it goes just like the GDR through WAR. Oh, I'm sorry. Yeah, there is a field. So in here, this approval status. If you look at the approval status, they've kind of overloaded the field now, so it has like people's names and a whole lot of other stuff in it. But essentially, the first part of it'll have one of these categories. It'll be investigate if you're still working on it. It'll be recommend accept if you're going to send it to WAR, and that's how they come up in WAR. That's how the query catches them, and they actually get reviewed in WAR. So recommend accept. Recommend reject means you want to reject it. Those generally won't come up in WAR. It'll just be the developer and everybody kind of agrees on it, and then you'll reject it. Approved is when the WAR team looks at it and they decide that it should be built. They'll set it to approved, and then the build team can actually build it. Rejected means that the build team rejected it. You need to look at why they rejected it. They'll put some information down here in the description field. Maybe they didn't have enough information. Maybe they didn't think the customer impact was strong enough, and you need to go get some more of that data, that kind of thing. Or they'll set it to reject. Yeah, that was reject. So yeah, it'll be one of those. Sure. So the question was, this one got closed out as a code defect, but there is no approval status. So the question was, how did that happen? So this was opened up as a code defect. It was resolved over here on this date by this person, and it was resolved as by design. By design bugs will never go to WAR. So that's why it doesn't have an approval status. So if you activate the bug, some of the different issue types, generally everything's a code defect if it's a bug. There are DCRs, that's a design change request. That's when somebody's requesting a change in default behavior or new functionality. Docs, that's just for the release team. That maybe denotes that they need to write a KB article about this or something like that. Redist, test bug I'll go over in a minute, but that's a bug just for the tester. That means you need to create some automation or create some tests to further test this in the future. And work items, just something. It's not actually a bug. It's just maybe a change in a process or something that needs to happen. Okay, bug check-in. So after it's been approved in WAR, the developer will complete a dev template, which is a web page that they go to, and they enter a whole bunch of data about it, about the bug. Then they check the bug into the appropriate source depot branch, and they complete a bug build request form. So the build request form, just like the GDR build request form, tells the build team what binaries to include in the next service pack, any inf changes that need to be made, any registry changes that need to be made, all that kind of thing. The bug gets resolved as fixed, and it gets assigned back to test. So, okay, right after, sorry, I think I skipped a step here. When it gets resolved as fixed, it gets sent back to test. The tester will wait until that build, and you can, there's a website that I'm sure will be covered later on in the week, the build team's website, where you can go and you can type in a bug number and it'll tell you what build of the service pack it came out in. That's how you know that your build's available and that it's ready. So you want to keep watching that. Also, if you query it in Product Studio, it should tell you the build number. That's not always 100% accurate, but it should tell you the build number of the build that it got built in. So yeah, so once you get that build number, you verify that it was fixed in that build. Then you need to do something called bug analysis. I don't know if you've had that training already. If not, you'll have it later on in this week. But it's a process that we came up with to address a few problems that we have with bugs. You also need to do this process for GDRs and QFEs. But a couple of the major problems that we had with bugs is maybe a bug had come up and we'd fix it in Windows 2000, but nobody ever looked at XP or Windows Server 2003 or NT4, and maybe the bug exists in one of those other platforms. So now there's a process where if it is a regression and we did fix it, then we'll open a bug against all of those other platforms, and even Longhorn, the future version of Windows. We'll open a bug in all those and assign them to the right people so that somebody can manually go through and verify that it either is a bug and we need to also fix that platform, or it doesn't exist for whatever reason. One of the other problems that we had was test holes. So if theoretically, once the version of Windows has already been shipped and we find a bug, if it wasn't, well, then there's a problem in the testing, because we should have caught that bug before we released Windows. If you're in like Service Pack 5 and we're still finding bugs, then there's obviously a hole in your testing. So as part of the bug hole analysis, we open up a test bug, like I just showed you in that issue type. Put test bug in the title, first thing in the title, and that's meant for the component owner to actually go back, figure out how their testing missed that bug, and write new tests that would catch it if, for whatever reason, that fix fell out of the build, which happens on occasion. It gets overwritten or whatever. And then look at that whole area and maybe write a whole bunch of new tests around that area to make sure that we'd catch any bug in that class. Right, so that's the purpose of bug hole analysis, or bug analysis. And there's a whole process that they'll go through for that. Okay, build. So I went over this just a little bit, but so interim builds of the service pack get billed on a schedule depending on what OS we're working on at the time and what stage we're at. So like I said, like Windows 2000 SP5 builds are probably coming out maybe once a week or so, maybe even less than that. XP SP2, we just finished beta and we're working on RC of that now, so builds are coming out every day on that. Server 2003 SP1, I think they're on a daily build schedule too, but you'll get mail on that tells you every time a new build comes out, and you can also check their website. So when a build comes out, after it's been produced, before it's actually released, it goes through the same BVT process as the QFE, and that's just to catch common errors. So, occasionally a private will work, and it includes some dependent binaries, and then for whatever reason, when the check-in got made and the final thing got built, it missed one of those dependent binaries, so you install it and it blue screens the machine or that kind of thing. So the BVT process will catch that. We'll also catch like base header address issues and things like that. So once it goes through the BVT process, it gets propped to this share, WinSE QFE/release, and build mail gets sent out. So that's where you can pick it up, and there's a whole directory structure under that. But once it gets propped in there, it's past BVTs and it's ready to test. Bug verification. I think I already went over this, but this is basically the bug. Once the build comes out, gets assigned back to the component owner. Test it, verify that it actually got fixed in the build, and that there's no other obvious areas obvious bugs right around it. Okay, so then in here I just listed some of the process contacts. So if you'll see email from most of these people at some point, probably a lot of email from some of these people, and if you have more questions about any particular piece of the process, you can talk to them and they give you some more information. The development contacts, just so you kind of know who these people are. Alan owns the entire dev team. He's the dev manager. And then he's got 5 leads under him. Manil owns the test org, so he owns all of the test team, and these are all of his managers, and then under the managers he has leads. So you'll see mail from them. The PM team I didn't list, but the main ones that you'll probably see email from will be Ralph for all the MSRC issues, and Sid. Sid will send out kind of the weekly status and daily status and all that kind of thing. So, questions? All right. Thanks a lot.